the problem of computer vision and vision systems so far, in my opinion, has been to look at pieces in isolation. A solution is to try to replicate the human visual system in one single block. So we're going to take a look here and ideas or how we're going to do this with our knowledge that we develop in this course, in particular deep networks. So the biggest problem of vision, really, if I think about all of its components, is really the following. Many people might agree with me, is that the object has to be found in the background at all times in order for us to be able to reproduce part of our agenda, which is this visual intelligence, being able to track target of interest while they are on the scene. So object has to be found in the background. The problem is you cannot remove the background, and it's very hard to segment the objects. And you cannot just learn the object features without the background, because then your network might not work very well. So it's very hard to try to figure out how there's an object there or not. Right now we looked at deep networks that they categorize, and but we haven't thought about how we could use those networks to track objects and to find them in a cluttered background. Partly we solved this problem, or we showed this problem, by training a large data set with backgrounds and objects. But we saw that this can also cause problems. There are also algorithms where you would really want to have a very precise segmentation of the object from the background. And if you remember, convolutional neural network subsample the image at each step. So once you have a pixel at the output space, that is usually a pixel that corresponds to many pixels in the input space. So you don't have very precise localization. You might sometimes want to have this. So let's look at these isolated pieces that computer vision has been talking about, trying to break down the problem. One of them is segmentation. Segmentation means that I want to segment different part of an object from the background, like a tree. We'll look at a tree, for example. A tree is composed of green area, a green part, and a brown part, the trunk, that look very similar to other objects, like the rocks in this scene. So it might be quite difficult to really try to segment an object without having knowledge of the whole system. And I think this is really the key element that makes me think that a lot of work in segmentation, great work, we try to locally exploit features in an image, it's not going to go much further than the work done by Pedro Felsenswap, which I think is one of the greatest work in graph-based segmentation. And I recommend you guys look at some of the papers from Pedro if you're interested in this. But basically always looks at local information. Is one pixel likely to be close to the other if it's fairly similar in RGB space? But in case like this, you cannot, for example, combine the whole tree has trunk and foliage, because they look quite different. Some people might say, well, those are two separate objects, there's the trunk and the foliage. But some people might think that they should be combined together. And also these local techniques might have a very hard time to distinguish, from a rock in the background and in the trunk when they are very, very similar. Of course, it's a lot easier here to distinguish the sky and maybe this special rock here that has more of a bluish or reddish color. In fact, you could use faster color segmentation by basically doing the equivalent of reduction on coding on the color information. So you can for each color plane, instead of having 8 bits, you could have 2 or 3 bits, and then you would get an image like this. this sort of segments a lot of the parts already together. Notice though that the sky gets, even though looks fairly uniform in here, gets segmented into multiple parts, because when you do color segmentation you have a big difference between these two. So combining maybe color segmentation with this, some of this technique might be the best. But I mean, really the problem is that you can't really segment things if you don't have information about the object as a whole. That makes me really think that the best segmenting tool is most probably a convolutional network. So problem is that this is not a unified also method. It looks at things in isolation and also may perform a lot of redundant computation in the first layer. So I don't recommend to use separate segmentation tools, but I recommend people to think together with me on ways that we can segment using convolutional neural network that also extract features about the object. So we would have a notion about the complete objects, and we would have a notion of where this object might be, even though we might not have, for example, a complete version. So the problem of segmentation, I don't recommend using it separately, but using it as not as a system in isolation, but as a system that together works with a convolutional neural network or a deep network to do what we want. So this is easier said than done, because actually up to now there's not a huge amount of work in using deep networks and segmentation. So if you want to find the proto-object, so even if you don't know what an object is, but even if you have no idea, what could be a tree or not, but you want to group things together, you might be able to group similar features, area that look similar either in color and texture, or areas that move together, and you definitely might need prior knowledge of objectness or what's a complete object if you really want to segment the full object together. So the real problem is that up to now we still don't have good models that can do this at once and in real time. And I really recommend people starting to think about this issue, and the idea of how we could possibly try to segment using deep networks, the same deep networks that is used to do categorization.